Yeah, hi, and thanks for stopping by. I tried to react to some comments, but in the moment I clicked on them, they vanished. I know cheese makes thirsty, but remember to drink water too. Funny coincidence with the number. Uh, we are in the Alps somewhere. I don't even know if that's Italy, Switzerland, or where we are, Austria. Cima da Flix, Piz Dagnel, Piz Piquol, Piz Surgonda. It might be Switzerland still, I don't know. So anyway, this is a mountaintop, and I don't know if that's Google picture quality or is that rock really that red? Might be. There could be really heavily iron-bearing parts there be in the Alps, and you can see the separation which happened vertically since the material flew in this way, and the electrical circuit connection upwards and downwards happened on that. So that's why the stuff got gathered here. Electrostatic. I try to remember this one word. Separation. Electrical separation. Static separation. I don't remember. But anyway, that's one interesting part of this mountain. And you can also see like the liquid forms in the rock itself. So now, let's go to the other side, which is more green, or how to put it. There has obviously happening some rock fall here, you can see, or it's just like snow fell and took some dirt down there. We got dirty snow. But Vadret Calderas. You cannot click on that for some reason, but it says Caldera, which I find really interesting. Furthermore, if we watch from above, and we watch just this area where we have ice, there are two regions of the ice which have a different kind of pattern. They aren't white. For whatever reason. Here's the other one. So now, this might be another piece of evidence for my theory about glaciers, their formation, how they came into being. There's actually a small one here too, which is liquid. Seems like. You can even see like there's probably water on top of the ice going to that, and then it continues downhill. So, it's a mountain. It's on top of a mountain. You can see. It's not the highest, but it's on top of a mountain. And my theory, I try to explain it really quickly. It's not on scale what I draw now. Yes, I figured out that I can push pause button so we don't have to wait. Now, electrical discharge, which is happening from above to the ground. Is it ground to ground discharge or from atmospheric to ground discharge? Doesn't matter after all, basically. But here, down here, we have different kinds of layers, bedrock and such. And as you can imagine, this blue one here is water. There might be water lower down here that's just simplification. It. Anyway, water is attracted to electricity, is a good conductor, and so on. So it makes the connection and it keeps the connection alive. It will get pulled towards that. And when the lightning bolt hits the ground, it will create a shock wave and stuff was flying around. But since we have this discharge event going on and there is static electricity, the stuff will gather around the lightning bolt. And as long as there is water rising from underneath, there's stuff, debris, and dust, and all kinds of things what you have. Neanderthals' houses and those cars and all these kind of things. They just are gathering around this lightning bolt, and when the bolt is off, we have a mountain. And since the water which is coming from underneath the crust is a really, really important factor in terms of conductivity. It might leave marks on top of a mountain. And I believe things like these. And actually, this could be really good proof for my theory of how glaciers got created. Why we have all those thousands and thousands of springs high, high up in the mountains. There is no other reason for why the water should come down from the mountains, even though everybody knows that the water is coming from the mountains. But why? I try to explain why. This is how I see things. This is my theory of glaciers. And one point is also really crucial to understand, that the creation process was such that there was this electrical discharge, really strong winds, earthquakes, and whatever. The craziest thing you can imagine, what nature can do. So, the Alps, which means the mountains and the valleys, are created simultaneously. There has been one event. After the event, we had a really huge pile of rock, which we call nowadays the Alps. And due to the elevation of those water bodies up there, and size differences and all these kind of things, I don't know where we have been before, somewhere here, I don't know, Pizzella, I don't know, Lenzerhorn, Alplihorn, Arosa, doesn't matter. All these mountains, they were created in one single event, And because of the elevation and the temperature, which is much cooler up there, 3,000, 4,000 meters above sea level, things freeze. So many of those water veins, they just froze. But since there is so much energy stored underneath Earth's mantle crust, where the water is, there's so much more water in the crust than you can imagine. It's just now stored under our feet. But it can come up. Liquefaction and such things, earthquakes. And the water is rising. We have seen it last summer in Koblenz, Germany. It's not always the rain, even though rain is also an electrical discharge event, which has always a reason why it's raining somewhere and somewhere it's not raining. Anyway, so after that, the water started to flow downhill, sometimes in an icy form, which we call glaciers. And if you watch at those, now let's just take a random valley. Now that's a valley in the Alps. There's water flowing in there, of course. We have boulders laying around all over the place. Erratic boulders. Sometimes they can be really big. Bigger than those houses. Much bigger, of course. And if we just follow this valley, I have no idea where we are, but it doesn't matter at all. We will find some kind of spring-like feature. I don't know, is that a rock glacier? Yeah, you heard right. There's such a thing like rock glacier. Scaletta Glacier. So we found a glacier. Surprise. Are these rocks? I don't know. Might be. But anyway, we have those patches here. Oh. Where is my pen? There's another one. So that's really steep, obviously. And it could be that these are the springs of the whole glacier. This is where the water's from, pouring out of the ground. And here we had a little crumbling of the Alps since the permafrost is softening the Alps. They're starting to crumble. They're not frozen anymore as they used to be in the last 12,000 years or something. Things change. And we have lakes. Jurisen. So now, how those boulders got in there? There's like boulders, erratic rocks everywhere. Okay. There's actually a third lake there in the background. So where is the water coming from? Which feeds those lakes? And the boulders. If it has been so, as told in school, that all this here in the middle, all that area, everything which is missing got carved out by glaciers, then I really have to ask one question again. Where is the pile? Where did all the material from those glaciers go? Here are the lakes. And all that here in the middle, all that is missing. And I claim, yeah, we still didn't find any pile. The lakes are somewhere here, and now we came all the way down here. And there's still no pile. Not one single pile. Maybe they just sold it to someone. That's why Switzerland is so rich. I don't know. But maybe there hasn't been any pile ever. The Alps got created as they are now. The glaciers formed afterwards. This is why we have the wells. This is why we have craters and calderas and all these kind of structures. How can I change the perspective? Here's a button. Yes, thanks. We can see flow patterns already here. Yeah, that's actually a good find. Haha, check it out. So now, this glacier obviously goes to two directions. Oh, damn. I might be wrong, but it somehow looks like it goes to that and that direction. So now, let's just follow the glacier. Silveretta Glacier. Okay. Look how smooth rocks we have here. And we have here smooth rocks, which already have this kind of curved shape. And then, that's the really end of the glacier. This is where the glacier ends. And it doesn't help how close I zoom in. There's no pile. Nothing. We have lakes and these kind of interesting patterns. More lakes. And here's a lake. Where's the water coming from to that lake? Doesn't make sense. Yeah. I'll probably leave it here. This might be the best proof of glaciers don't form any valleys or whatsoever. Yeah, this looks really interesting. Bit spoon. Yeah, I'll leave it here. Bit spoon. You'll probably find it. Still, no pine. No pile. Not a pine. No pile and a caldera. Thanks. Bye.